for the confirmation. Yes. Hi, everyone. Good evening. Thank you for joining today's session. Thank you for joining today's session. Just give me a second. And we are into the 5th day of our core Java session that we have been taking since last week. So we have done 4 classes till now, and we are into the 5th session today. And by this time, most of you guys have some flavor of Java programming. Like you are able to understand the classes, you are able to uh, understand a few bits and pieces, or the things, whatever I taught you till now. My intention was to give you 100% learning experience. So with that, I want to take this class further into one more extra topic, which is the B loop. So as every day, let's see what is the agenda that we are going to learn for today. By the way, what is our agenda for today? Our agenda is, so let's say this is, or let me go to my actual class notes so that I would append. I am opening it with Notepad. So this is my class notes that I have been taking and was sharing with you every day. So let me quickly add. This is class number 5. Okay. So what is our agenda for today? Let's see. What are we going to learn in this class? What are we going to learn in this class? So we are learning the following things. What is a method and why do we need methods? So if you remember, I've been speaking about main method, or I can say a test class, etc., etc. Right? I can say, just give me a second, guys. So I've been speaking about the main method. I've been speaking about the test class, etc., etc. So you are already familiar with that terminology of something called as methods. Okay. So let me see what is the one more thing that I'd be speaking about today. That is static. What is that? Static method declaration. Static method declaration. And the third point that I'd be speaking about is the static method usage. Static method usage. So before I actually dive into the definitions or anything like that, I want to just give you some, kind of overview of this. In my programming, I have a few things to be done. Like, for example, I have step 1, step 2, step 3, step 4. There are 4 steps that I want to do. Okay, there are 4 steps that I want to do, and I want to do them multiple times. I want to do them multiple times. So there is some mechanism, or you can say, yeah, you can call it as a mechanism where you can take those 4 steps, club them, call it as a method, and whenever you want to perform those steps, you can simply call that method, right? So in simple understanding, method is nothing but if there is something common that you want to do, that common thing or common code, you can make it as a block, and that you can call as method. Let's actually see the definition. Okay, so this I would obviously be sharing this to you. Let's see. Let me just read out some basic definitions for you guys. So what is a method? What is a method? In Java, method is a block of code that performs a specific task. As I told you, let's say you have a task to perform, then you can write that task description or what is the code that is required for that task to be done into a block. That block is called as a method. One more thing, method should be defined inside a class. You cannot have a method outside the class. So always the method should be inside the class. And you can invoke the method to do a particular piece of task, right? These are the simple things which are related to methods. Now I told you that if you are doing some task again and again, you can put all those into a method. But why do we exactly need a method? There are a few points that I just want to highlight. Let's quickly see what are those points. One is the code reusability. When I say that I have a particular task to be done in multiple times, by using methods, I can write it only once and call it multiple times so that I need not write it again and again and again. This is code reusability. And one more is the modularity. Let's say you have a very big task. You can break that into 10 tasks and say maybe put each task into a method, which means you can break a very big piece into 10 pieces and each piece you can assign it to a method. In that way, you are making it modular. Modular means not having a very big concrete one, but you are having everything into pieces and pieces so that it would be easier for you to maintain. That is the third point. What is this maintainability? For example, you have a class which is dealing with different things, right? There is some problem that came to you. There is some issue that you have to look into. So let's say you have modularized that, you put all your code into a few methods that are easier for you to organize. Then you can easily find out where it is breaking, go to that method, and then make the changes. So in that way, you can maintain the code in a better format. Now, last is the readability, right? You can name a method saying that it is doing a particular task. For example, I want to write a method to print something. I can put the name of the method as print. I mean, I'm just saying, by seeing it that I know that, okay, I'm doing something called some task related to printing inside this method. Let's say I have a method called init, right? I will have something like the initialization logic in that. So in simple words, you can, by using methods, you can do code reusability, you can follow modularity, you can achieve maintainability, and you can have more readability. Enough with the theory, guys. I just want to take some analogy to you so that you can correlate to what I'm actually speaking in this last 5 minutes. Let me just quickly come down. I want to just show you an analogy. An analogy. Let's say you went to a cafe. Let's say you went to a coffee day. Okay. There are various coffee machines that are present in that coffee shop. So that coffee shop can be called as a class, right? There are different coffee machines, right? You can think them like methods. What is each coffee machine doing? It is producing coffee for me. What is each coffee machine doing? Coffee machine is producing coffee for me. Let's say for each coffee machine, we have different types of coffees. We have a cappuccino, we have an espresso, or let's say you want to just get milk, or you want to just get hot water, etc. You have the way to achieve that using this coffee machine. So there are a few buttons that are present on the coffee machine. They will indicate, is it a cappuccino? Is it an espresso? Is it something else? Those you can correlate as the method names. Any name is can be correlated to the coffee that is present in that coffee machine. And let's say there are various ingredients. Okay. So let's say I pressed on cappuccino. It will take the coffee beans, it will take milk, it will take some water, it will mix everything, and finally it will try to perform or it will try to give me coffee. So those ingredients are called as parameters, which I'll be discussing next when I'll be speaking about the syntax, right? And then the brewing process, whatever is written inside the method body, right? That is called as the actual task. What is the actual task of this coffee machine? Is to prepare a coffee, right? That can be thought like a method body, right? That can be thought like a method body. And finally, after I press the button, I get a coffee, right? That is called as a return type. We can just correlate that to a return type because I pressed on a task or I clicked on that method. I'm getting the return, which is a coffee that is already prepared by my coffee machine. So what is my coffee machine? That is a method in my analogy. So you can just correlate the things so that you can understand, what I'm trying to speak. So with this, let's quickly go to some examples. Let me take down. Let me take down a few things. We have till now seen our program. Let's say I quickly open. Okay, I opened the variable 2. Here, if you can see, public static void main string array of args. We have been speaking about this method since last 4 days. We have been speaking about this method since last 4 days. We are calling it as main method. We are calling it as main method. All right. So this is one such example. Let me quickly go and take the syntax for this. So what is the syntax? Let me show it to you. Let me show it to you. My syntax. What is my syntax? My syntax is this one. Or let me write it down so that it would be easier. What is this? First, we'll have access modifier, access modifier. Then, as I told you, today's class would be related to static. Okay, today's class would be related to static. So I will just say static. Okay, then I will have a return type. Then I will have method name. Then I will open my curly brace. I will close my curly brace, and whatever is there inside this is the method body. So one such example that I want to take is I will say public. I'll say static. I want the return type as void, which means I do not want to return anything. Maybe I want to name my method as process. Okay, I want to name my method as process. Let me open the brace and let me close the brace. So what I want to do is I've taken some small example. Here I want to do processing logic. Right? This is the syntax. And this is one such example of my method. Guys, if you think what is this access modifier and why did I write public? Actually, there are 4 access modifiers: public, private, default, and protected. I'll be speaking about each access modifier in depth, in detail in the further classes. But as of now, you think that public is an access modifier. When I say something called public, then anywhere in my code base, I can go and call this method. From anywhere. I can call it from my same class. I can call it from my same package. I can call it from a different package in a different class also. So public is like, okay, I'm open for everything. So what is the static? As I told you, we'll be discussing about the static method declaration, static message usage for today. So that is why we have a static over here. Okay. Void, it is nothing but a return type. Process is the method name. Let's see one more example. The example that we are all very familiar with. Public, static, void, main. Okay. So I will say string array of arguments. Okay, so this is one more example. I'll say main method body. So I have public static void main string array of args, and I have the main method body. This is one more example. Okay, so what I want to say here, this is also a static method, and this is also a static method. What I actually meant by static. What is static? Guys, you all are, okay, before I say what is static, I would like to even say one more thing. Let's say if I remove the static from here, then that is called as an instance method. Let me show it to you over here. There is the static, which I have highlighted. There is the static. Now, there are different types of methods also, which we will not be discussing in depth today, but we will be discussing about all these in our upcoming classes. But for now, if you do not have static, if you do not have static in the syntax, then you can think that method as an instance method, or you can think that method as a non-static method. So this is non-static method. Let's park this, for all the details in the upcoming sessions. But as of now, we will be dealing with static methods. So when I say something related to static, static means I can say in simple words, one per class, one per class. There is a class, by the way. In that class, if I have something called as a static, then it is a copy for that particular class. Or in simple terms, let me tell you an analogy. Okay, there are so many students in the class. Let's say, okay, there are so many students. Every student has a book and a pen with them. Every student has a book and a pen with them. That book is an instance for a student. Every student has a book. Okay, that is non-static. Okay, every book is non-static because one student has one book. But in that class, there is a blackboard or a green board, right? There is only one board for all the 60 students in the class. There is only one board for all the 60 students in the class. So that is called as static. So which means one per class. If you are saying something as instance, it is one per object. Okay. So static means the one that we are having per class. Let's quickly try to write a few. Let's try to quickly write a few examples, or maybe let me try to take some notes over here. I will say, let me take some quick notes over here. What did I speak about? If static keyword is present, it is static method. The other thing that I wanted to say is if no static, then it is instance. Then it is instance method. Okay, then it is instance method. One important thing that I want to speak, or I have already told you, is if you say something as static, then if static, then what I actually mean, it belongs to the class. It doesn't belong to an object, but it belongs to the class. This is what I wanted to say. Let me just. And one more important point to be noted down over here is a method should always have a return type. Should always have a return type. One example that I have given, what is that? Process method, it is having a return type void. Let's say main method, it is having a return type void. Now let's say, maybe I'll take one more example. Public static int destroy. Okay, so when I say destroy, let's say I will have all the destruction logic over here. I mean, I'll say all clear up logic, like making the objects to be garbage collection eligible, etc., etc., which I'll be speaking about these details. Okay, let's not confuse the mind at this point. But here what I want to do is it is returning an int type. Okay, I just want to say if destruction or if clear up successful, then what do I do? Return 0. If clear up fails, I say if clear up if clearup fails, then you return 1. I just want to just give some example over here. I have a return type called int. There is a method called destroy. If there is something successful, I'm returning 0. If there is something failing, then I'm returning 1. Right? This is a return type. In our coffee machine example, as I told you, if I press on cappuccino, I should get cappuccino coffee in return. If I press on espresso, I should get espresso coffee in return. This is called as the return type. Okay, so the method should always have a return type. Now, there is one more important point. What is that? If you do not wish to return, then you need to use void. If you do not have anything to return, then you have to use void. Like for example, we have public static void main string array of args. It is having a void. Okay, which means main method is not returning anything. As I previously told you, main method is being called by JVM. Let's say you want to return some value to it. What will JVM do with it? It does not do anything. JVM just calls your main method and say, okay, I have already called. I don't have anything to do with the things that you are returning. That is what JVM says. So that is why main method is also not returning anything. But in our case, there is this destroy method. Destroy method is returning some value called int, right? So when it is returning some value, what I want to say is it will be returning 0. If it is successful, it will be returning 1 if it is a failure. Okay, so let me write down one more very important point, which is my 6th point. Method can take one or more arguments. So arguments, or I can say, yeah, we can call it as arguments. If I can take this example, public static void main string array of args, it is taking one argument. It is taking one argument. And if you take destroy method, it is not taking any argument. If you take process method, this is not taking any argument. This is not taking any argument. So these are very important points to be remembered while we learn something about the methods. Let me quickly try to explain all these to you using a few examples. Okay, using a few examples. So what do I need to do? Let me create a new class. Okay, I'll say new. Let me close this one. Let me close this one. I want to create a new class. We'll be following the same steps that we generally follow. What are those steps? Let me quickly revise. This is my class. This is my second class nodes. What is the thing that I need to do? These are the things that I need to do to write a Java program. I need to open a Notepad++. I need to select language J and Java. Then this is already there. A new folder has been created. I need to save my file as classname.java. I need to compile it using javac command. I need to run it using Java and class name. Let's do the same steps over here. I want to say class. Maybe I'm saying my class 1. I want to say it, or I want to call it as my class 1. So what do I need to do? Language J and Java. I selected Java as my language. Let me quickly open the curly brace and close the curly brace. Let me quickly open the curly brace and close the curly brace. Just a second, guys. Yeah. Let me open the curly brace and close the curly brace. Now, what do I need to do? I should say public static void main, and what is the string array of arguments. String array of arguments. Let me open the brace and let me close the brace. So what is this? This is a main method. As I told you, this is a access modifier. We'll be speaking about it in our further classes. This is static. We are actually dealing with the static methods. What did I tell about static? Static is nothing but one per class. I told you one more example where there are multiple students going to the class. Let's say there are 60 students. Every student has a book. That is an instance. Book is an instance for that student. But all 60 students will have one common blackboard or the green board, right? That is static. Okay, if you declare something, a method or a variable as static, you mean that it has one copy of that method or a variable in that class. It is only one copy, right? You cannot have multiple things. Now, this is static for you. Void is nothing but my return type. If I do not want to return anything, I just simply say void. Okay. And main is my method name. As I told you, main is my method name. And these are the arguments that it is taking. So let me try to quickly print, right? Let me try to quickly print something. What do I want to print? System dot out dot println. So what do I want to print? I want to print main method starts. Okay. So I just want to say main method starts. And I want to say one more thing. What is that? I want to say one more thing. It has started. I do not have anything. Now I want to say ends. E-N-D-S. Main method is starting and my main method is ending. Right? My main method is starting. My main method is ending. Let me quickly say this. I'll say double click, right click, copy, file, save as. How do I save it? I have desktop Mercy as my folder. I want to paste my class name dot Java. I did this. So what is my next step? I need to cross check if a .java file is created or not. My class one. Let me go to Mercy folder. I have my class one. It is a Java folder that got created. What is my next step? I need to go and open my command prompt. What do I need to do? I just need to click on this Windows CMD. I have to type CMD and I have to just open the command prompt. All right. The moment I open it, this is the black screen that gets opened. This we are seeing since many days. But what is the shortcut to directly open in my folder? I directly can go to Mercy and I can click on this address bar, press CMD, and then you can see the path got directly changed to my desired location. Let me increase my font. Okay, let me increase my font. I just giving enter so that other people can also correlate or understand uh, see this visually in a better shape. So what do I need to do? Java. See, this is my compilation. This is my this is my compilation. This is my compilation command. What did I extra do? I just need to I am copying my class one. Okay, I just copied over here and I say sorry. So I go to my class one, right click, copy. I did this, and now I'm saying right click. Give me a second, guys. Okay, Java C. Let me quickly cross check if there is any problem. Public static void main string array of args class. We are opening the curly brace. We are closing the curly brace, and we are naming this as like this. TRIND Let's see why this is having a problem. I'll say Java C class name dot Java. And yeah, I think maybe I have added extra spaces, so that is why it was taking some problem. I don't have any problem in compilation. That is why I see some black screen over. I mean, a blank screen or a blank text over here. Let me directly go over here and see cross check if my .class file got generated or not. Yes, I see a .class file. Now, what do I need to do? My next step is to run this. It is Java and then class name. And I say enter. You can see this main method starts, main method ends. Main method starts, main method ends. By the way, who is calling this main method this? This main method is being called by JVM. I think we have previously discussed in our program to understand what happens in the background. What happens in the background when you try to run a Java program. We have seen the diagram. So main method is being called by JVM. So you can see it over here. We are printing these two lines. Now, let me quickly write one more method and see, what happens. I want to write one more method. I want to say public public static, I can say void, and I want to name it as process. Let me name it as process. I want to open my brace and then close this. Okay, I want to close this. Now, what do I need to do? Let me quickly print system.out.println. So what do I print? I'll say process method. I will just say inside process method. I'm just trying to print this statement. I'm trying to print this statement. Let me try to quickly save this. I will say save. Okay, let's try to run and see what happens. What do I need to do? My steps are follows. I cleared everything. Let's say Java C. What is my class name? It is my class one. I'll say copy. And what do I do? I'm pasting this and say Java. When I do this, yes, it is compiled successfully. What is my next thing? Java, my class. Okay, Java, my class. When I say this, you can see this main method starts and main method ends. Main method starts and main method ends. So only these two are there over here, guys. Only these two are there. Let's try to understand why. Okay, so let me try to actually write. I mean, maybe it's a good practice for us. If we see something, we want to write some comments, right? So what is that? I can say this part from line number 10, it is like method declaration. It is method declaration, right? It is method declaration. What do we call this? What do we call this? There is a method called process, and we are declaring this method. So just for your understanding, as I have previously told you, these comments are ignored by compiler, and it is only for programmers understanding. This is fine. I have a process method. I have written something over here inside process method. When I try to run, I'm only seeing main method starts and main method ends. I'm not seeing inside process method. Why is it so? Uh, there should be some reason. The reason is nobody is calling this process method, right? Nobody is calling this process method. Then you may ask, like, who is calling this main method? The answer that I have already given it to you. Main method is being called by JVM. JVM saying, hey, main method, yes, I found you. So let me call you. And JVM called this main method. But I have a process method, which is just alone. Nobody is calling it. So it is just over here. It is not doing anything. Right? Let's try to call this process method. Let's try to call this process method. How do we call it? How do we call it? We call it in this way. It is just the method name. I will say process. I have this method name and I have the open and curly closed parenthesis, and I don't have any parameters, right? That is why I'm not passing any parameters. What do? I am calling this process method from my main method. I'm calling this process method from my main method. Let's see what happens. I'll say I'm saving this. I'm saving this. Let's quickly see what happens now. Okay, let's quickly see what happens now. I'm clearing. Let me quickly go here. It is Java C. What is my class name, by the way? My class name is my class one. I'm copying this and I say this dot Java. When I do this, yes, I don't have any problem. Now let me run this Java, my class name. That's it. So you can see this, guys. Main method has started. Main method has ended. And then I'm seeing one more line, which is inside process method. Inside process method. So what is happening? JVM has called my main method. It is saying, hey, main, I found you. You can start executing line by line. Okay. It came and see, okay, there is some statement. Let me print this. There is some statement. Let me print this. Oh, somebody is calling this process method. By the way, there is a process method. So let me go from line number 7 to line number 11, where it is declared. So let me go here. What is there inside this? inside the process method. So it is there something called inside process method. Again, I have to print something. So let me print this. So which means that main method calling is done by JVM, and all the other methods that you declare should be called by you only. If you do not call the method, then it will not be invoked. Okay. So let me write this important point. Let me write down this important point. Let me write down this important point. We need to call the method to execute the logic, execute the statements inside it. So we should call the method to execute the statements inside it. There are two ways of calling static methods, guys, which we will be coming to it, after playing around with a few more programs. Okay, after playing around with few more programs, let's come to the ways of calling static method. Okay, now I want to modify a very small thing over here. I want to modify a very small thing over here. If you can see, line number 7 is there, right? I'm just taking this line number 7. I say control X, which means I do not want to call it at line number 7. I want to call it at line number 6. I want to call it at line number 6. That's fine. JVM will call the main method. It will come to this statement. It prints. Then I can see a process. It is called. Then this line should get printed. And then it should come back and print the main method ends. First, JVM calls this. It is printed. Now process method is there. Now this line should get printed. It should come back and call this method. Okay. Now this is what my actual understanding is. Let's see if this actually works in this way or not. Okay. Let's see what will be the output right now. I'm clearing. I'll say Java C. I'll say Java C. This is my class name. Let's say copy. I'm saving this. Okay. So dot Java. When I compile this, I don't have any problem. Now, what is my program to run or command to run? I say Java, then my things. You can see this, guys. Main method starts. Then the next statement that is printing is inside process method. And the next statement that is printing is inside main method. Let me copy this. Okay. I just copied all this text. Let me quickly paste it over here. I want to paste it over here. And let's see what happens. The first statement that got printed is this line number 17, which is main method starts. That is because of this print statement. Later on, a process method is called. That is why this inside process method statement is getting printed. And then after it is done with the execution of whatever is there inside this process method, it is going back to see if there is anything left out. Yes, there is one more statement that is left out. And that is why we are getting the main method ends. That is why we are getting the main method ends, right? So this is how the method execution logic is. How, what happens? How do we invoke the different methods and what is the calling pattern? Okay, this is how it goes. Now, just to be very clear, let's do one more thing. Let's do just one more thing. Okay, let's do just one more thing. Just one more thing. What is that? I have this process method. Okay, I have this process method. Now I want to print something like this. I just copied over here, copy, and then I'm pasting it like this. I have to paste some lines. I just want to paste some lines. After this, I'm again trying to call my process method. I'll say I'm selecting this text, right click, copy, and then I'm pasting it once more. I'm pasting it once more. Okay, I'm pasting it once more. But just for your understanding, what I would like to do is here I just want to comment saying calling a method, or I can say calling process method. Right? This is calling process method. Let me copy this and then again I want to say calling process method, right? My program is now modified into the following thing. Main method starts. I'm calling a process method. I'm printing something over here. Again, I'm calling process method and main method ends. Let's see if we can do it or not. Here, what we are doing, guys, we are calling the same method 2 times. Are we allowed? Are we allowed to call the same method 2 times? Let's quickly find out. Let's quickly find out. Okay. So what I say is, I'm trying to compile my Java program. What is my class name, by the way? This is my class name. I say copy and to save this, right? Say dot Java. So I'm compiling the same class again. I say enter. Oh, now you see there is no problem whatsoever, right? There is no problem whatsoever, which is an indication that we can call the same method multiple times. Let me quickly write down before I forget. So I just want to write it down. What is that? We can call a method more than one time. Okay, we can call a method more than one time. Okay, there is no restriction. There is no restriction. Yes. Now try to run this. Space run this. What is the command? Java and then my class. Let's say yes. Now you can see this, guys. Let me copy this so that we can actually understand what is happening. This is my output. I want to paste my output over here, right? So main method is starting. Main method is starting. I'm calling the process method. When I call process method, what is there inside this? I'm calling this inside process method. I'm done with all my execution part over here. I came back. I see on line number 8, there is some lines that are getting printed. So that is why lines got printed. Now, again, I'm calling this process method. We have seen a rule that we can call the same method more than one time, right? So that is why I'm printing this inside, inside main method once more. Just a second. After this, dotted lines, I'm calling this process method. That is why I came to this inside process method. The same is printed over here on line number 24. Now, after I'm done with both these, I go back, right? There is no other statement except printing main method ends. So you can see this main method ends. So guys, how is the invocation happening or what is happening? First, JVM will find out if there is a main method. Yes, there is a main method. So it will call the main method. Now in main method, sequentially, line by line, every method or every line gets executed, right? So this line number 5 is nothing but it is just printing something. Line number 7 is nothing but calling a method, right? This is the syntax for calling a method. When you call a method, the control goes to that method and try to complete all the statements that are present inside that method, right? And then control comes back and see what is the next thing that it needs to do. So in simple terms, JVM calls main method. The statements gets executed one by one. If there is a method call, the control goes to that method, does all the execution over here. It comes back, it prints, and it goes sequentially one by one. And at the end, it completes its last statement and finally quits. Finally stops. So this is what happens when you try to execute or call the methods. Okay. Now I just want to have one more thing. What is that? I have a user defined method. Like even this main is also defined by me. I just want to have one more printing statement over here. What is that? I want to have one more printing statement over here. I will say process method starts. And here I want to say process method ends. Okay. So can I do it? There is one more method that I have written. I'm writing two statements in it. I'm writing two statements in it. So is it allowed? Am I allowed? Let's quickly find out. I want to compile this. So I cleared all my history. I say Java C. What is my class name, by the way? My class name is my class name. I say I copy this and go here, copy. and then paste, and then I'm saying .java. So I'm able to compile this properly, which is an indication that I can have more than one statement in my method. This is a simple point, but since we have encountered, let's write it down. More than one, or I can say 0 or more statements can be inside a method. So a method can either have no statements at all, or it can have more than 0. There is no end count to it. You can have any number of statements inside a particular method, right? Let's quickly try to play around a little bit more. As I told you previously, guys, this is the calling part. This is the calling part. This is the calling part. There are two ways to call a static method. There are two ways to call a static method. Let me quickly write down. Let me quickly write down. What is my 10th point? There are two ways to call a static method. There are two ways to call a static method. What are they, by the way? Using the method name. This is inside the same class. Okay, inside the same class. Then another one is using, what is this, class name dot method. Where can I do in this way? I can call inside class or outside class using the method name. I can say directly. Okay, sorry. I can directly call using the method name. This is one way. And then the other way is by using class name dot method name. Let's experiment both the ways. Let me quickly go to the same program, right? There are two places that I'm calling process method. What is one way? As I've told you, one way is directly calling using the method name that I've already done over here, right? What is the other way? The other way is by using the class name dot method name. Can I do it? Let's see. What is my class name? My class name is my class one. I'm copying this, copy. I say my class one dot method name, right? This is the second way of calling. I can just say directly calling process method. This is one way. And then calling process method using class name. Okay, this is what I'm doing using class name. This is one way and this is the other way. Let's see what happens. I'm saving. So by the way, my output should be the same as my previous output. Okay, my output should be the same as my previous output. We can even, see how the output looks. Or let me quickly save this. First, try to run the same program. I'll say clearing the screen. Java C. Wait, let me give you more enters so that people can understand. So I go here, copying my class name. Let's say copy. Now I call it as Java C class name dot Java. And I do this. You can see I don't have any problem, which means my dot class file should have been generated. So what is my command to run? Java class name. I say enter. You can see this, guys. Let me quickly copy all this and paste it in my program. Right. What is this? Main method is starting. Yes, line number 5 is printing. Now I'm directly calling the process method. So which means the control is going to this. I'm printing process method starts, or for our better understanding, guys, let me just quickly change this one. Process method starts. I want to say process method ends. I say process method ends. Okay, I say process method ends. I just changed the printout statement, by the way. Let me try to quickly run this once more. Java C. What is my class name? My class name is this. Let's say copy and class name dot Java and then Java class. You can see this. Let me copy my output. Let me copy my output fully. I copied, and I would like to analyze this. What is this? Main method starts. Yes, line number 5 got printed. Now we are directly calling the process method. We are directly calling the process method. What it says, the next two lines are process method is starting, process method is ending. Process method starts, process method ends. Now the control comes back, it comes back to line number 8. I'm printing this, dotted lines are equal to symbols. Yes, I'm done with. Now again, I'm calling using a different way of calling. What is the different way of calling? Using the class name. Using my class one, I'm calling the static method. Again, it's the same story. The process method starts, process method ends. The control comes back to line number 11 and we are printing the main method ends. So these are the two ways. These are the two ways of calling. These are the two ways of calling the static methods. Now, we have seen how the propagation, like how do we propagate from main method to a different method, etc., etc. As I told you guys, let me just try to play around just once more in this. Okay, what do I want to do? What do I want to do? What do I want to do? I want to write one more method. What do I want to do is want to say clear, or I want to say destroy 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 connections, destroy database connections. I can maybe this is my main motto, DB connections. Okay, this is what I want to do. Now, what do I want to do? I can say public static. I want to name my method as destroy, but before that, I want to return it. I want to return something. I can say I want to return some int value. I want to return some int value and name that method as destroy. I want to name that method as destroy. Okay. I want to name my method as destroy. Okay. So what should happen here? Sorry. Okay. So what should happen here? It should have, this should actually have logic. This should actually have logic to what do you call destroy DB connections. Okay, this should actually have logic to destroy DB connections, but I'm not focusing about all these methods or all these things. What is the logic, etc., etc. I just want to return something. Return. Maybe I want to return a value called 10. Okay, I just want to return a value called 10. Okay, this is destroy. Now I want to have one more method, guys. Let me have one more method. What is that method? Init DB connections. So don't get confused. What is a DB connection, etc.? It is a database connection that has nothing to do with the core Java classes that we are doing right now. Maybe you'd be learning about all these connections, etc., etc., as you grow further or as you go further. So just think that this is a particular method and it has some logic to it. So I'll be having one more method. What do I want to name it as? Public. I want to say void init. Init means initialization method. I want to name that as I'll say system dot out dot println. I want to name it as did I write static? Okay, let me write it static. Okay. So this is a static method, system dot out dot println. What I want to say, DB connections established or DB connections successfully. Okay. I just want to print this statement. In my init method, initialization method, what I want to do is I want to say the DB connections have been established successfully. Okay. Just for this is for my learning purpose, right? So I want to have this over here. Again, in my method body, it will have logic to initialize DB connections. It will have the logic to initialize DB connections. And here I have the logic to destroy the DB connections. I want to even print something. I want to print something. Okay. I want to DB connections destroyed successfully. So I have two methods, guys. I did not do anything else. I have written two methods. One is a init method for initialization purpose, and another is a destroy method. What is the difference between these two methods? Init method is a void method. It is not returning anything to me. But destroy method is an int method. Maybe I can have a logic of returning how many connections that I destroyed or something like that. Just for our, just for our current learning, we can say that we are returning some value called 10. What is its significance? Let's not even consider about it. Just think that our destroy method is returning a particular value. We can do something with this value, which we will be learning. Guys, in the same program, what we have added is, till now, we have added a process method. We played around with this process method and we are all good. Now, I have written two more methods. One is an init method and another is destroyed method. What is the common thing between both init and destroy method and even process method is all of these are static methods. All of these are static methods. Let me quickly say this. Now, I want to see the calling pattern for the same. I want to call these methods and just want to play around. I want to call these and just want to play around. What is that? I will say first, before I even start my process, I want to call my init method. Before I even start processing something, I want to call my init method. So what do I say? I just say enter over here and I want to directly call init. I want to directly call init. On line number 6, I'm directly calling init method. Let me try to write my method comment over here. Directly calling init method. Directly calling init method. What is this? This is init method. Okay. Once I'm calling init method, I want to start my process. And once I'm done, I want to print something. And again, I want to call process. And then towards my end, I want to destroy my DB connections. For that, let me call destroy. How to call? I'm using the first way of calling this. I just copied. I say copy. Destroy method I'm calling over here. I'm pasting this. Okay. So, but if you can see the beauty of this destroy method, what is it doing? It is trying to print something, but it is returning something also. It is returning something also. Let's try to see if we can do something with whatever has been returned. So if you see, yesterday we have dealt about the variables, right? What is this one? It is returning int. So what I will do is, what I will do is, or instead of increasing more complexity, right? Let me remove this second process method because it will be having more system.out.println statements which doesn't give a good visibility. So I'm calling a process method. What I did is I'm printing this system.out.println. I'm calling my destroy method directly. So when I call destroy method, I'm returning an integer value to it. So let's say I want to capture this, or I want to store this variable. Yesterday, if you remember, what is a variable? Variable is nothing but it's a place to store something. So let's say I want to say int x equal to destroy. So I'm calling this destroy method. Whatever it is being returned, I'm storing that in a variable called X. I'm storing that in a variable called X. Let me try to print if that actually is being returned or not. I will say system dot out dot println. So when I do this, I can say X equal to, and I want to print X. I'm not doing anything else. I'm directly calling destroy method over here. My destroy method is returning some value called 10 that I'm capturing into a variable called X. And the same thing I'm printing on line number 12. I'm not doing anything else. So with this, let's try to quickly run this program and see what happens. What would be our output? So guys, for the people, okay, it will be very short in font. That's fine. I just wanted you to guess the output, but I cannot show the whole program right now. So let's quickly try to copy, do this Java C. I want to compile my Java program. I already copied my class one. Let's say dot Java. Can I do this? You can see there is no problem whatsoever. By the way, guys, without even knowing, we have written a program with just 37 lines. So just simple lines of code. Okay, so let me try to compile this, which I have already done. Now let me run this Java class. When I do this, you can see this. Now let me quickly copy this so that we can understand line by line what had happened. Okay, what had happened. So main method starts. Yes, this is my main method starts statement. And now what is my next one? DB connections established successfully. Why did this line come? DB connections established successfully? Because before I even process something, I'm calling my init method. What is my init method doing? Init method is saying the DB connections are established successfully. Yes, after I have established the DB connection successfully, I will go back and I'm calling process method. What happens? Here process method has started, process method has ended. These lines are already here. Okay, I'm just printing these lines. Now, before I destroy, I'm directly calling destroy method and I'm taking the return of my destroy into a variable called X. Okay, so the moment the destroy gets called, whatever is there in that destroy will be printed. What is this? DB connections destroyed successfully. This is what I see over here. Now, my return type is 10 and I am printing X equal to 10 on my line number 12. This is what I've been doing. And finally, my main method is ending. You can see this. And finally, my main method is ending. So guys, this is how the static methods are being called internally. The method calling happens internally. And then we can visualize all the story that is happening using these statements that got printed on the console. Using these statements that got printed on the console. So guys, with this, we are able to learn about all the points that I mentioned over here. And let's see what was our agenda for today. Our agenda was to learn about what are methods and why do we need it, which we have already seen, the static methods and declaration, the static methods and their usage. The static method and their usage. Guys, I'll quickly go through it. And after I go through, I just want to, I just remembered one more thing. I want to revise the yesterday's topic just once more. I want to give you a sample program of different variables. I want to just show that into a single program. So let me quickly revise whatever we have learned for today, and then we can go back to that topic. Our agenda for today was what is a method and why do we need it? The static method declaration and the static method usage. As I told you, method in Java is a block of code to perform a particular task. In our example, we have seen init method is doing the initialization task, opening up the DB connections. Destroy method is doing the destruction tasks, closing the DB connections, etc. So all the methods are defined inside the class only. All the examples that we have seen till now, there is this class, and this is opening on line number 2. This is closing on line number 37. And we have 1, 2, 3, and 4. There are 4 methods. All the methods are written inside the class. There is no method. There is no place for the method to sit outside the class. Okay, that is something that we have already seen. And a method can be invoked to execute the task. If you remember our first or second program where we had just written the method, but we did not call that method. So no process, inside processing method, the statement did not get printed. The reason is we did not invoke. But method gives us a feature where the block of code that is used to perform a specific task can be executed by invoking it. Okay. Now, next what we have seen is why do we need methods? One point was code reusability. We can write it once and call it in multiple places. Like for example, in my same example, let's say I have written a method called init. Okay, I want to initialize my DB connections in my class 1. I can use the same method to do the same in my class 2, my class 3, my class 4, my class 5, in multiple classes. I can use the same method. I need not write this method again. Like for example, if you are working in a team and your task has been given to work on this DB connections, etc. If you write a method, then after 1 month, there is one more person who got a similar task. What he will do is instead of writing the whole logic, he will just call your method. That's it, nothing else. Right? This is the beauty of working in the team. You have already spent maybe a week on that. Now the other person who comes in, he just calls that method. He doesn't even care about what is happening inside that. So in that way, you can write it once and can be used it in multiple times. Modularity is to break the program into smaller and manageable parts. Again, if I go to the same example, this program or this class is doing with processing, is doing with initialization, is doing with destruction. So all these things you are making into tasks. Initialization task all goes into init, destruction task all goes into destroy. So in that way, you are categorizing all your statements inside your method. That is what this modularity says. And maintainability is easy to update and fix the specific parts. Now, let's say there is some task, a new task that came to you in your project, saying that in the init method, what are we doing? We are initializing the database connections. Let's say till now you're using Oracle database. Now, somehow they do not want to pay for the license and they want to use MySQL, but because that was a free database. Now, you need not touch the process method because it has nothing to do with the initialization part. You have to only touch two things. One is the init method and the other is destroy method, because these two are the methods that are dealing about DB connections. Now, what did you change? You changed Oracle to MySQL. So you just need to come to these methods and change. And then if I go to the readability, the moment I see in it, I can somehow think that there is some initialization code in it. The moment I see destroy, I can think that there is some destruction logic in it. So by looking at the name, I will know what is there or what would be there in that method. And later on, we came to the syntax of it. We have an access modifier, static, return type, method name, and arguments. One such example is public void process. As I told you, static is something that is a keyword that is used to indicate that it is a static method. If we do not have it, then we call it as instance method or non-static method. Now, if we quickly go to our notes, whatever we have written, if the static keyword is present, then we call it as a static method. If the static keyword is not present, then we are calling it as the instance method. So one more thing that I told you is if there is something called static that belongs to the class, as I told you, let's say there are 60 students in the class. Every student has a book, right? There is one book per student. That is called as an instance. Book can be an example of an instance. But the blackboard or the green board, which is only one board per class for all the 60 students, it's only a single board. So that board, you can call it as static. So I can say it belongs to class. It is one copy per class. Okay. The method should always have a return type. That is what we have been seeing. We have public static void main. Void is a return type. Int destroy. Int is the return type. So If you do not want to return anything, then you have to use void, but at any cost, you should have a return type. One more thing is the method can take one or more arguments. I can say not one, zero, zero or more arguments, because we have a destroy method. There is no argument. Init method, there is no argument. Process method, there is no argument. Main method, it is taking string arguments, string array of arguments. So you can have zero or more arguments into a method. Now the other point is we need to call the method to execute the statements inside it. If we do not call, or if we do not invoke, then the method call itself does not happen. We can call a particular method more than one time in our code. We can even leave it. There is no compilation error, but that will be a dead code. Nobody even cares of it. So if you declare a method, make sure that you're calling it. If not, then you can remove it, because that would obviously be a dead code. And the other point is zero or more statements can be present inside a method. You can write a method and just leave it like that. There's no problem. Compiler doesn't say anything. Java doesn't have any problem with it. Okay, but good practices, you need to have the method name, and all the actions that are being done in that method should correspond to whatever you have written. It's not like, okay, I will name my method as print and I will write destruction logic in it. Right? Somehow a person, like a new person, comes and says, oh, this is the print method, let me call it. And somehow he ends up calling database connections destruction. Then it doesn't make any sense. It is actually misusing whatever Java is providing to us. So the last point is there were two ways of calling a static method. One way is directly calling using the method name, and the other way is by using the class name. So guys, with this, we are able to complete our agenda for today. But as I have told you, we will be speaking a little bit more about the variables part that we have spoken yesterday. The variables part that we have spoken yesterday. So let me quickly revise. What is a variable? What is a variable? If I take some real world example, let's say you have a purse, or you have a wallet, and you are holding some currency notes in it. You are holding some ATM cards in it, right? That purse is a variable. What is it doing? It is holding something, right? It is holding something. That wallet or the purse that you have in your pocket is a variable. Is a variable. Now let's say I can say, maybe I can give some example of wallet, or maybe I can put something called water bottle. Water bottle. Let's have a water bottle. What do I use my water bottle for? I use my water bottle to store some water. Okay, to hold some water. So the water bottle becomes a variable. This is some real world analogy of a variable. Okay, so if I quickly go to my second class notes or my previous class notes, I have these primitive types. I have these primitive types. Let me take all these primitive types and then want to paste it just to understand a little bit more. Okay, just to understand a little bit more. What are the primitive types, by the way? Byte, short, int, long, float, double, boolean, and character. Let's only consider byte, short, int, long for now, because I want to speak something related to the holding of numbers. Okay, so I just want to say byte is having a capacity less than short, and short is having a capacity less than int, and int is having a capacity less than long. So all these are the data types: holding, integer, or I can say whole numbers. Whole numbers. Guys, you have to memorize one thing: byte, short, int, long. Byte is for smaller capacity, Short is for little bit bigger capacity. Int is for even bigger capacity. Long is for the longest capacity. Okay, for holding the whole numbers. Just if I want to take some example, maybe byte, let's say 1 kg. Let's say I want 1 kg bag. Okay, I want to say 1 kg bag is less than 5 kg bag. Okay, so this one is less than 10 kg bag, and 10 kg is less than, like for example, let's say 50 kg bag. Okay, I just want to give it a 20. Okay, so byte is less than short, short is less than int, int is less than long. The analogy is 1 kg bag is less than 5 kg, 5 kg is less than 10 kg, 10 kg is less than 50 kg. Here, very important thing, important point that you need to remember is, let's say you have any material, having weight, equal to, let's say 2 kg. Okay, you are having a material who is having weight of 2 kg. Okay, so you cannot obviously put that in a 1 kg bag because that is not useful for you. You can obviously put that into a 5 kg bag because it's just 2 kg. It can accommodate, still 3 kg is left. You can put this 2 kg into 10 kg also. But what happens? 8 kg is left. You can put this 2 kg into 50 kg also. But the problem is 48 kg is still left. What I wanted to emphasize over here is we have byte, short, int, and long. These are various data types for holding some data. Yesterday, I have shown you some table. You need not even memorize all those numbers. But what I want to emphasize is if you want to hold some value, and if you are taking a particular data type, then you should make sure that you are not, unnecessarily misusing your memory. Like, for example, if my requirement is to hold something in int, there is no point of taking long, because let's say my capacity is 5 kg or my capacity is 7 kg. I can take an int which can carry up to 10 kg. If I take long, there is no problem. There is no problem whatsoever. But I'm just misusing the memory. I'm just misusing the memory. Let me quickly try to, or let me go a little bit far ahead. Now this is for whole numbers, right? We have something called float, float, which is less than double. Float, which is less than double. What does that mean? Float is less than double. What is this? These are decimal numbers. These are decimal numbers. So here again, I can give the analogies. 1.5 kg is less than 5.5 kg. So this is, guys, I'm giving you all this kg. These are not for some notation. I'm giving all this because you can correlate in future, saying that, okay, if I'm going for a float, if I can do something with float, let me do it with float only. Let me not go to double. If I can do something with int, let me do it with int only. Do not go until long, right? This is a good programmer's practice. By the way, even though this table says we can use byte, we can use short, but in my last 10 years of IT industry experience, right, I rarely see people using byte or short. I rarely see people using byte or short. People generally use int, and if they want to store something which is very big, they go for long. But as a programmer or as a learning person, you should know that there are different data types, and you should actually know when to use which data type. There are others also, guys. Boolean and character. These are simple things to learn. Like Boolean is nothing but true or false, as I told you previously. Character is like the one that we store in a double quote. Okay, so this is something that I wanted to cover in primitive data types and something that I wanted to cover in float and double. So let me quickly try to write a very small program and then demonstrate so that we can close for today. I want to open. Okay, maybe I will try to take this variable to class. Okay, I do not want to add anything new. So here, let me take down my primitive types one by one: byte, short, int, long. I can say byte B equal to, let's say 10. Okay. Short S equal to, let's say 100. Int, let's say M equal to 1000. And then long L equal to 1000, or maybe I can say 5000. Okay. By the way, if we need to declare something as long, we have to add a small l. If we add a capital L, then there are auto boxing, auto unboxing, etc. would be involved. But this notation, when I say it is ending with L, this is not one, guys. This is L for Lucknow. So this is being held in this variable. Let me quickly print all this. System dot out dot println. Let me print. Let me print B equal to plus B. Okay. So let me try to take all these. I have 4 methods. I want to say S equal to S, and I want to make it M equal to M, and I want to say L equal to L. By the way, you might be thinking, no, why did I use B for byte, S for short, and L for long? Why did I use M for int? Actually, naming these variables like B, S, M, and L itself is wrong. But since we are in learning phase and we are not developing any project, we are not having project specific names. This is for our learning purpose. But generally M, why did I take M? I can easily take I. I can easily take I, but generally I is a value that we generally use for loops. For I equal to 0, I less than 10, I plus plus. For j is equal to, for k is equal to, these we generally use in loops. There is no convention as such. Nobody has written even in the documentation. But as programmers, we are used to all that. So that is why whenever I see some variable called I think it is related to some loop. So I avoid using that kind of variables. So this is all the numeric types, or I can say whole numbers. I can say whole numbers. I can say whole numbers. So let me even go with my floating point numbers. Or I can give a better decimal numbers. What are my decimal numbers? Let me quickly take some example. What are my decimal numbers? It is not byte, but it is float. Float, I'm making as F, and I can say 10.5 F. Okay. And then I have double. I want to name it as D, and I want to say 100.6 D. Okay. If I do not give D, it again takes as, by default, it takes as what do you call that? Double. So then one more, which is Boolean. Okay. So what is that? Boolean. Boolean. Bool. I already have B, guys, so that is why I'm not using that. Boolean bool is equal to true. Okay, I just want to print. Okay, before I forget, let me print these also. Copy, and I want to print my variable called F, and I want to print my variable called D. Okay, I want to print as F, and I want to take it as D. Okay, Boolean. I want to print my Boolean. Copy. Okay, so what is this? Bool equal to, and I want to print Boolean. One last thing, what is that? One last thing, what is that? Char. Character. So what I want to say, char c equal to, maybe I want to put this in my single quotes and I want to give a. Okay. And what do I want to do? I want to print my character as well. C. I want to print C. Okay. So guys, this is what we have done. I've taken a single class, and in that single class, I'm dealing with all the whole numbers. I'm dealing with all the decimal numbers. I'm dealing with Boolean, and I'm dealing with character data types. These are all primitive data types, by the way. Let's quickly try to run this program and see what is the output. Let's go here. Let's say, okay, Java C class name dot Java. Yes, it is compiled, and the class. See this? You see this, guys? Let me quickly take this and paste it in my notes. I'm seeing BSML, BSML 10, 100,000, 5,000. BSML 10, 100,000, 5,000. You can see this. This is what I can see. And F equal to D equal to, what is my F? It is 10.5 and double 100.6. You can see, why are we not seeing L over here? Why are we not seeing F over here? This L and F is Java to understand, for Java to understand, not for us, right? Just by seeing .5, just by seeing .6, we understand that it is something related to floating point. It is something related to double, okay? But those notations are for Java compiler to understand, and we do not have anything to do with this, okay? And then we have bool. We are taking this variable, I'm printing this, and I'm printing my character as well. So this small example, small programmatic example will give you a better idea of all the primitive data types. And I have actually even spoken about the sizes of those data types. Okay. If you are going for very less quantity, use for byte, a little bit more, go for short, little bit more, go for int, even more, go for long. But in general practice, programmers use int and long. Okay. And in general practice, programmers use float, or if you are looking for very, very big, decimal number, then you go for double. Okay. So with this, guys, I think we are done with today's lecture. I think we are good to stop at this particular juncture.